All right, so now we're into the basics of velocity and acceleration. So velocity, remember, is how fast an object is moving in a certain direction. And the equation I said was velocity equals displacement as represented by the letter S. Displacement's base unit is meters. I need to close a parentheses there. So displacement S divided by time, times base unit seconds. Velocity's unit meters per second. That's all in base units. So let's solve a few problems. One, what is the velocity of a car that travels 36.0 meters in 18 seconds? And I want us to go through the steps of problem solving. So the first thing to do is to draw a picture and label it well. So I sketched out a fast picture. Please do not worry about trying to make your pictures beautiful and artistic. Get the picture down. Don't worry also if you're not an artist. I am definitely not an artist. But a picture helps me visualize and think about what's actually happening. Plus, in the picture, I use that as an opportunity to identify what my variables are. For example, here is time, 18 seconds, and here is my displacement, S, 36.0 meters. Now that I have identified my variables, make a quick variable bank. This almost makes, whenever we have multiple equations, it almost makes picking the right equation multiple choice. V equals question mark. That's the goal. That's what I'm looking for. S equals 36.0 meters. T equals 18 seconds. Now, pick an equation. You only have one, the velocity equation. Rewrite the equation, V equals S over T. And now I'm going to substitute in and solve. Notice how here, whenever I'm working this, I look to my equation bank, my variable bank, and I say, okay, I know what S is, plug in 36. I don't know what V is, so leave it as V. I know what T is, right? So plug in 18 on the next line down. Working in a linear manner here, working in a very linear manner. Now, this might seem a little bit of an overkill on such a simple problem, but I need you to get in the habits of actually going through this process, because whenever the problems become a lot longer, a lot hairier, a lot bigger, take a lot more time, there's different equations to use, you have to pick them, there might be multiple parts. You need to have these sort of habits. Picture to visualize, to think about the physics, and a variable bank. Then you can pick an equation, substitute it in, and solve. It will make hard problems very, very easy. Also, notice in my final answer, I rounded for significant figures. 2.0. Why 2.0? Well, check out sig figs back in the problem. There were 3 significant figures here in the displacement, 2 significant figures here in the time, so I pick the number with the least number of significant figures, and I round my answer to that. That's the multiplication division rule for significant figures, and it's the only one we're going to need in this class for right now, aka 2 sig figs is the lowest, so I must have 2 sig figs on my answer. I also make sure that I'm putting in the correct units there. Number 2, how far will a car travel how far will a car traveling 25 meters per second go in 2 minutes? So once again, I'm going to draw a picture and go through the problem-solving process. All right, so I went ahead and drew my picture here and did my variable bank. And in my variable bank, I notice a problem. My time right now is in minutes. That's not the base unit. Base unit for time is seconds. Plus, check it out, minutes, meters per second. It does not match. I need to convert my time back to seconds. So doing my quick conversion that we learned in the last unit, I find, and you already knew, that this is going to be 120 seconds here for my time. Now I'm going to rewrite my equation and substitute in. And now all I need to do is solve the algebra. And the way you're going to do that is by, notice the S over here in the numerator, the thing that I'm looking for. I plugged my V in for V, and my T 120 seconds here came in T 120 seconds. S is my unknown. It's what I'm looking for. I should have emphasized this a little bit more. Key terms. What is the velocity, right? That's pretty obvious. You're looking for V. How far implies a displacement or a distance traveled here, a displacement. So I'm looking for S. That's the unknown. Another way to identify what's what is check out the units. Meters per second is a unit of velocity. Minutes is a unit of time. So if you look at the units, you can always identify what that variable is or what it's supposed to be. Now back over here to the algebra, multiply both sides by 120 and I figure out my displacement. And whenever I multiply 120 over, I come out with 3,000 meters, but looking back at significant figures, 3 sig figs in the velocity, 3 sig figs in the time, meaning my answer, lowest number is 3, I need my answer reported to 3 significant figures. 3,000 only has 1. If I put a decimal at the end, it would have 4. So I come back to scientific notation. 3.00 times 10 to the third meters, or times 10 to the third we know means kilo, so you could report 3.00 kilometers as your displacement time. Your displacement, S. Number 3. How long? Now, how long implies we are looking for, I need to know what time is. I don't know what time is. How long, Mom, will it take before we get to the beach? How long, Dad, do I have to stay here in the car? How much longer? So how long time? Will it take a car going 21 meters per second? There's my velocity to travel 0.420 kilometers. There's a displacement. So once again, sketch a picture and then write down everything we know and what we don't know, a variable bank. All right, so there you go. And one of the first things that I notice is I have kilometers. That's not a base unit. Plus, it doesn't even match kilometers and meters. So I need to convert my kilometers back to meters, back to base units. And I remember my nifty little trick. Kilo just means times 10 to the third. And I'm not worried about proper scientific notation here because it's not the final answer. I just get to write 0.420 times 10 to the third meters as the displacement. Now I rewrite the equation and solve, and I'm going to give myself a little bit more room and scroll down. All right, so I substituted in. Now it's time to solve for my unknown t. My time was what I didn't know. It's what I'm looking for, so I made sure to leave that in there. Time, right? I didn't know time, so I left that in there as t. I'm going to come out with t equals something. By the way, you might be a little freaked out by this idea, 0.420 times 10 to the third. Don't be. Your calculator handles scientific notation without any problem. If you needed to do this mentally in your head, you could. You jump the decimal 3 times. It would be 420 meters. It's really not that big of a deal. But I do want you to get familiar with scientific notation, because there will be many measurements that you will have no choice but to use scientific notation. And whenever you become good at it, it really takes no thought as you get used to using it on a calculator. Now, algebra here. I have my time in the denominator. Whatever's in the denominator, I have to get out first. I can't multiply both sides by 0.420 times 10 to the third. That will do nothing productive for me. I need to multiply the t to the other side to start out with. And now I can divide both sides by 21. And I come out with a final answer of 20 seconds with a decimal at the very end of it, 20 seconds. 2 sig figs because 2 sig figs in the velocity, 3 sig figs in the kilometers, the displacement here. So I need smallest number, 2 significant figures to my time, thus the decimal there. All right, our next equation, acceleration, is the final velocity minus the initial velocity divided by time. And so here that is laid out for you there with their correct units. Acceleration has base units meters per second squared. Notice the squared there. Sometimes you'll see that written ms to the -2. Number one, what is the acceleration of a car that starts from rest? Whenever you hear starts from rest, that means, starts. Rest means zero velocity. So starts from rest, that's going to be u, or an initial velocity of 0. So u equals 0. Let's just pin that in up there. And accelerates up to, now this is going to be my final here, v, 25. And hey, now it gives me a time, t 5 seconds. Now you won't always see the initial velocity stated before the final velocity. It'll come vice versa. Just read the question and you'll be fine. So it starts from rest, accelerates to 25 meters per second. All right, so I drew my picture and then I created a variable bank down there. I'm going to pick an equation. This is an acceleration equation, so I'm going to use acceleration now and solve for my unknown a. And whenever I substitute in my numbers and I go ahead and work the algebra, because a is already solved for me, it's already on the other side. A equals 25 minus 0 divided by 5, that's final minus initial divided by time. I come out with 5 meters per second squared, unit for acceleration meters per second squared. Also notice two significant figures, because up in the problem, all the numbers given were given to 2 sig figs. Number 2, a car speeds up to pass a semi-truck on the interstate. Car's already going 25 meters per second. That says initial velocity u here. Accelerates for 3.5 seconds. Seconds is a unit of time, t, at a rate of 2.5 meters per second squared. Meters per second squared is the unit of acceleration. What is the car's final velocity? I'm trying to find v in the end. So now draw a picture, create a variable bank. All right, so I have my decrepit-looking picture here with my semi-truck here that we're going to try to get by, kind of all squeezed into the small space that I left myself to do this video. And my variable bank over here, my initial velocity, final velocity is what I'm looking for. I've told the acceleration and the time. Now I'm going to use the acceleration equation, the base acceleration equation. Let's go back to the other color. A equals final velocity minus initial velocity u divided by time. Substitute in and solve. First step here is to multiply the 3.5 over to the other side. And now add the 25 over. And I come out with 33.75, but I only have 2 significant figures from all of the initial given data, or the initial given variables in the problem. So I have to round 33.75 to 2 sig figs. It becomes 34 sig figs. Units for final velocity, units for velocity is meters per second. Number 3. Last problem, maximum braking deceleration of a certain car, 3.5 meters per second squared. If the car is going 23 meters per second, how long will it take to stop? So let's give ourselves a little bit of working room here, and then we're going to draw a picture and give a variable bank. Now think about what's actually happening here. The car is going forward right now 23 meters per second. U, or initial, right? So it's already doing that. And it's trying to stop. That's why I put my v here in the picture. The final velocity is 0. That's the goal, trying to stop. Stopped means 0 velocity. But we are decelerating at a rate of 3.5 meters per second squared. So your acceleration is actually going to go back the other way. Acceleration 3.5 meters per second squared. Now, I haven't mentioned this, and it's going to become very, very important in upcoming problems and other videos. You need to pick directions for positive and negative. It didn't matter in all the others because we were all going, everything was going the same way. But if I call to the right, everything that's going to the right positive. For example, in my picture, the initial velocity is going to the right. Positive 23. The car is going to the right. That's the positive 23 meters per second. Any change in position would be positive. But the acceleration, aka deceleration, goes the opposite way. It's trying to slow the car down. It's trying to fight against the velocity. Deceleration is the same thing as a negative acceleration. An acceleration slowing the car down. We can talk more about that in class. And I'm looking for how long, aka I want to know what my time is, how long before the car stops. All right, so I created my variable bank. Notice that I made my acceleration, because it's deceleration, it is negative, and that is critical. I've got to slow down my initial velocity to a final velocity of 0. If this was positive, we'd be speeding up. And then I rewrote my equation. Now plug in and solve. Notice it's final minus initial, so the final velocity was 0, initial 23, so it's 0 minus 23. First step here is to get t to the other side, so I'll need to multiply both sides by t, and I'll come out with negative 3.5t equals, now 0 minus negative 23 is just negative 23. Next step, divide both sides by negative 3.5, right, so it cancels out over there. Divide by negative 3.5. Plug into your calculator. The two negatives cancel out, right? Negative 23, negative 3.5. And I come out with a positive, because time is always positive. 6.571, so on and so forth, seconds. But I have to round to 2 significant figures, because notice up in the problem, 3.5 meters per second is 2 sig figs. 23 meters per second, 2 sig figs. The lowest number of sig figs given, 2. So I round to 2 sig figs. This becomes 6.6 seconds here for how long it takes for this car to stop.